Hey guys, here we are for lesson 10, the last lesson in the chapter 3, distinguishing circumference and area. We're going to skip 10.1, we're going to start on 10.2 on page 78. Now it says the teacher will give you a card sort with questions about circles. What we need to do is we need to figure out if these are talking about area or circumference. So let's go through these together. Number 1, how much fabric is needed for a round tablecloth? So if you think a tablecloth is used to cover the table, right? So we're covering something up, so that is area. Number 2, how fast are you riding on a Ferris wheel? Well, when you ride on the Ferris wheel, you ride around the outside of the Ferris wheel, so that would be circumference. Number 3, how much green space is there inside a traffic roundabout? Well, I think a roundabout. Inside the roundabout, that's covering all that up, so that's area. Number 4, how many square inches of cheese fit on any slice of pizza? Well, think of a piece of pizza, and we're putting cheese on the pizza, so we're covering it up, so that's area again. Number 5, how many times must a horse go around a horse walker? So we're walking around, so that's circumference. Number 6, how many feet are traveled by a person riding once around the merry-go-round? So we're going around once, that's circumference again. Number 7, how much room is there to spread frosting on a cookie? So we have a cookie, put frosting on it, so we're covering it up, so that's area again. And number 8, how far does a unicycle move when the wheel makes 5 full rotations? So 1, 2, 3, 4, 5, so that's circumference. Okay? So when we're talking about covering something up with a tablecloth or with frosting or we're tiling a floor, that's area. When we're talking about going like walking around a lake, a frame around a mirror, riding the merry-go-round or the Ferris wheel, that's all circumference. Okay, moving on, let's look at 10.4. We're going to skip 10.3, and we're going to talk about 10.4. So 10.4, here are 2 students' answers for each of the question. Do you agree or disagree with them? Explain or show reasoning. How many feet are traveled by a person riding once around the merry-go-round? So we're riding around the merry-go-round. So that's around the merry-go-round, so that's circumference. So remember, circumference is pi times diameter. So circumference is pi times diameter, or 2 times radius times pi. Okay, so let's see what Claire and Andre say. Claire says the radius of the merry-go-round is about 4 feet. So that distance around the edge is about 8 pi feet. So she took 4. That's the radius. So she multiplied that by 2 to get the diameter. 4 times 2 is 8. And then 8 times pi is 8 pi. So Claire's right. So we'll put a smiley face for Claire. Okay. Well, Andre says the diameter of the merry-go-round is about 4 feet, so the distance around the edge is 4 pi feet. Oh, so he says the diameter is 4, so 4 times pi is 4 pi, so they both did the problem right, okay? But one said the radius is 4 feet, and one says the diameter is 4 feet. So if you think about it, radius being 4 feet, or diameter being 4 feet, if the diameter was 4 feet, that would be a really small merry-go-round. Okay, so I'm going to say Andre is wrong in his guessing. His math is correct, but his guessing on the, or his labeling, the circle is wrong. Okay, moving on. Number 2. How much room is there needed to spread frosting on a cookie? So spreading frosting on a cookie, we're talking area, so it's pi times radius. So the radius of a cookie is about 3 centimeters, so the space of the frosting is about 6 pi centimeters. So radius is 3, so pi times 3 times 3, well 3 times 3 is 9, and 9 times pi is 9 pi. Ooh, he got 6 pi. She got 6 pi. Bad news for Claire. Okay, it says the diameter of the cookie is about 3 inches, so the space of the frosting is about 2.25 pi inches. So what Andre did is he took the diameter and divided it by 3 and got 1.5. And 1.5 times 1.5 is 2.25 times pi is 2.25 pi. So Andre did it correctly. Good job, Andre. And number 3, how far does the unicycle move when the wheel makes 5 full rotations? So we're talking about rotations. We're going around something, so that's circumference again. So remember, circumference is pi times diameter, or 2 times your radius times pi. So we need to find the circumference. Claire says the diameter of the unicycle wheel is about 0.5, which is 1/2. In 5 complete rotations, it will go 5/2 pi meter squared. So 1/2 pi, so pi times diameter, 1/2 times pi is 1/2. And then 1/2 times 5 is 2.5, which is 5/2. So Claire did it right. Good job, Claire. So she found the circumference, which is 1/2 pi, and then she multiplied by 5 and got 5/2. Andre says, I agree with Claire's estimate of the diameter, but that means the unicycle will go 5/4 pi. Well, Andre is wrong. It is 5/2, not 5/4. Okay, so that is it. So let's look at the summary on page 81. It says, sometimes we need to find the circumference of a circle, and sometimes we need to find the area. Here are some examples of quantities related to circumference of a circle. The length of a circular path, the distance a wheel travels after one complete rotation, or the length of a piece of rope coiled in a circle. Here are some examples of quantities related to area of a circle. The amount of land that is cultivated on a circular field, the amount of frosting needed to cover a cake, and the number of tiles needed to cover a round table. In both cases, the radius or diameter of the circle is all that we need to make this calculation. Circumference of a circle with a radius r is 2 times pi times r, while the area is pi times radius, or pi times radius squared. This circumference is measured in linear units, such as centimeters, kilometers, or inches, while area is measured in square units, such as centimeters squared, inches squared, or kilometers squared. Okay, on your assignment today, looks like we're going to do number 1 and number 3 in your book. Number 1, it just gives you situations, and you have to tell me, are they talking about the circumference, or are they talking about the area? Okay, and then number 3, we need to find both the circumference, or the distance around the field, and then the area of the field. Okay, so if you notice, on this, if the bottom is 250, that means the side is also 250. Okay, this part right here is the circumference, but it's 1/4 of the circumference. So find the circumference. My radius is 250. That means my diameter is 500. So if we go 500 times pi divided by 4, that's going to give me this part. And then just add those 3 numbers together. That's A. And then the area of the field, well, this is my radius. So pi times radius, and then it's 1/4 of the field, so we're going to divide that by 4. Okay? Remember, if you have any questions, just go ahead and send me an email.